This is the way I live. Little boy still pushing big.
Hey everyone, Miss McKay here. So today we're going to be writing real-world expressions, but we're also going to be evaluating them at a given variable. What that means is we're pretty much going to be solving how much money we would either make or owe, depending on the situation. So let's get started. So our first example today says, Karen bakes the same numbers of cookies each day in her bakery. So first, we want to write an expression to represent the total number of cookies Karen bakes in a week. So let's get started. So we already know that Karen makes the same amount of cookies each day. So we can call that X. We don't know how many cookies she's making, but we know that she's making the same amount. We want to know the number of total cookies that Karen bakes in a week. So there's 7 days a week. She makes the same amount of cookies every day. So how many cookies will be described as 7x? For part B, we want to know how many cookies will she have at the end of the week if she bakes 40 per day. So what that's telling us is it's telling us that x is actually equal to 40. So now let's plug in 40 for where we see an x in our expression and evaluate. So instead of 7 times x now, it's 7 times 40. 7 times 40 is 280. So that means Karen makes 280 cookies per week. Example 2 says, Angel lost a fourth of his body weight working out. Part A wants us to write an expression to represent his weight loss. So we know X is going to represent how much Angel originally weighed, because we do not, that's what we don't know. We don't know how much he started off weighing. So if he lost a fourth of his body weight working out, that would be X times 1/4. We want to know how much would Angel weigh if he used to weigh 200 pounds. So what they're telling us is that X is equal to 200. So when we plug in 200 for X and evaluate, we should get 1/4 times 200. What we're really doing here is we're figuring out 1/4 of his original weight, which was 200. 1/4 times 200 is the same thing as 200 divided by 4. We know 200 divided by 4 is 50. So that means Angel lost 50 pounds. If we were going to take it one step further for a real life scenario, if he originally weighed 200 and lost 50 pounds, he would weigh 150 pounds. In the end. Yay, good for Angel. Our last problem says, Phil gets paid $70 per hour, but he pays $100 per day to his assistant. So for part A, let's model Phil's daily pay. So he gets paid $70 per hour. At this point, we don't know how many hours he works, so we're going to represent his hours with X. Even though Phil makes $70 per hour, he still pays his assistant $100 per day. If he's paying her or him $100, that means he's subtracting that from his daily pay of $70 per hour. So this is our expression in part A. For part B, we want to know how much would Phil make if he worked a 15-hour day. So what that's saying is now X is equal to 15. So we're going to plug in 15 wherever we see an X in the above expression. So now instead of 70 times X, it's 70 times 15 minus 100. For PEMDAS, remember, always do your multiplication before any type of subtraction. So we will figure out 70 times 15, which is equal to 1,050. Man, I want Phil's job. and we need to subtract 100 from that to make sure his assistant also gets paid. So 1,050 minus 100 is equal to $950 per day. Man, tell me what you guys think Phil's job would be. I don't know. If you have any questions on this video or any of my other videos, you can send me a message on Instagram at Miss McKay Math. Have a good day.